Okay, so this video will continue on with this question, but for part B. So now we have found the 2 points. Well, we have found Q, now we have the 2 points. We want to find the directional derivative. So we have this equation. If you refer back to your textbook or anything, resources online, you know from those resources that the directional derivative is the gradient vector dot u. But in this case, we have 2 points. So we have, these are our known information. And another definition to find the directional derivative at a certain point in the direction of the unit vector is actually this function right here. This equation right here. Okay, so yeah, so it's as the limit h approaches 0, getting close to 0, we can find the directional derivative, which is the slope in that direction. So this makes complete sense from Calc 1 and into multivariate calculus, where we have two variables going on. So basically, for this case, it will just be f of q minus f of p, because we have the final point minus the initial point, and we have the function, which is here. I'll rewrite it just in case. We have the function f of x y equals. I have down here, but which I solved for each individual point. But yeah, so we know that h from part A is 0.1, that's the distance. So all we have to do is plug numbers in, and I can go along this with you. So I just did a little side calculation in pink down here, which will give us the function, and we have f of q, and then x plus y, and then square root of that, we get 3.01, and f of p, we get 3. So, and then we plug these two numbers back into our approximation equation to find the directional derivative. We get 0.1. So yeah, as the distance approaches 0, the slope will be 0.1, almost to very close. It gives us a good approximation. And just as a reminder, this equation up here gives us the exact value of the directional derivative, which we will find in the next video from all the information from part A and B. But this equation right here gives us the approximation. And how do we know it's the approximation? Because the limit, as the limit h approaches 0, this will give us the approximation of the directional derivative, or the slope towards that direction. Okay.